Evaluating hundreds of individual test scores by hand is a slow, repetitive process, and it practically guarantees human error. Python automates this evaluation process through conditional statements, logical rules that tell the program to execute different commands depending on the data it receives. We can build an automated grading system that takes a raw number and instantly routes it to the correct output, A, B, C, or D, based on a rubric we define. To follow along, make sure you have Python installed and a code editor like Visual Studio Code open on your desktop. These logic gates are the building blocks of software engineering. Every complex application, from social media algorithms to banking systems, relies on these same conditional pathways to function. First, create a variable called marks and use the input function to ask for the student's numerical score. By default, Python treats everything typed into the terminal as raw text, which it calls a string. You cannot perform mathematical operations on a string. To fix this, wrap the entire input line inside the int function. This casts the text into an integer, enabling Python to evaluate the score mathematically. Now we write our first rule for the A grade. Type if, followed by checking if the marks are greater than or equal to 90. End this line with a colon. In Python, the colon signals the end of the condition and indicates that a specific block of instructions follows immediately below it. When you press enter, you'll see a gap. Python uses this indentation, typically 4 spaces, to identify which actions belong to our if statement. Under this indent, type print grade A. This combination of the colon and the indentation creates a localized block of logic. The print command will only trigger if the student's score meets our 90-point threshold. That handles our top tier. Now we need to define what happens when a score is lower than 90. Since the 90 to 100 range is already covered, we use the elif statement to check the next tier. This only runs if the first if statement turns out to be false. To assign a B, we need a specific window. We set a lower bound of 80, but we also need to ensure the score is strictly less than 90. We write this boundary by using the logical AND operator to chain 2 rules together. Both must be true for this entire line to succeed. Complete this elif block by checking if marks are greater than or equal to 80 and marks are less than 90. Don't forget the colon and the indented print statement for grade B. Duplicate this structure for our third tier. Create another elif that checks for scores between 70 and 79 for the C grade. Defining these strict upper and lower boundaries ensures our logic is precise. It prevents a high score, like Erlangi 5, from accidentally triggering every single grade condition as the program runs. Finally, we need a way to capture any score that didn't meet the requirements for an A, B, or C. The else statement acts as a safety net. It catches any data point that drops through our previous rules without finding a match. Unlike our previous lines, else does not need a mathematical condition. Its only job is to handle the leftovers, so we just follow it with a colon. Under this final indent, print grade D. Your script is now complete, so save your work. Run the file in your terminal and test these 4 scores, 94, 88, 74, and 67. The output should match our A, B, C, and D rubric exactly. By combining if, elif, and else, we've built an impenetrable logic tree. Any valid numerical input is now automatically sorted with total precision. You have successfully translated a human grading rubric into a machine-readable script. However, there is a logical flaw. If a user makes a typo and enters a score of 150, our current script will still award them an A because 150 is greater than 90. To fix this, we use nesting. This is the practice of placing one if statement inside another to create more complex, layered rules. Here is your challenge. Try to nest a rule that checks if a score is 100 or less. If it's over 100, have the program print an invalid score error before the grading logic even runs. Intentionally try to break your script. Experiment with different boundaries and see how the machine responds to unexpected data. While these strict rules, the colons, the int functions, and the indentations, might feel rigid at first, these are the tools that allow us to structure our logic so the machine can take over the heavy lifting for us.